presently we are, or rather we've been introduced into a new age in human history, in which we now have smart cities, we have smart watches, we have smartware, we have everything smart. Now, how do these technologies reshape our urban life? And could you share a successful implementation from your project that has tackled this?
Thank you, Mr. Peter. See, we need to recognize one important aspect, what is happening in the world. Traditionally, we used to say that India lives in villages. That means most of the population lives in villages. If you look at the trend worldwide, by 2035, more than 50% of the population will be residing in cities. What is the concept of smart cities basically? You try to provide the basic amenities using the modern technology.
Welcome to another segment, and today we have with us Dr. Murthy, the Dean of Doctoral Studies. Sir, thank you for joining us today. Sir, before we get into the crux of why we're here, I would like you to kind of like give us a little background about yourself and most especially what drew you to sustainable practices or studies of technology.
Thank you so much, Mr. Peter, for having me on this talk. To be very honest with you, our journey started way back in 2007 November when I joined Parul Seva Mandal as a professor and director of Parul Institute of Engineering and Technology MBA program. From then, one critical area that I focused upon is how important it is sustainability in the context of global warming. Well, in 2015, we had an invitation from Federation of Indian Chamber of Commerce and Industry, which is the apex body of trade and commerce, at the initiative of the Royal Academy of Engineering for a discussion on importance of academia and industry interactions to develop academy in a proper perspective. I was really lucky to have the support of the entire management of Parul University. I must acknowledge that first. That point of time, the president was Dr. J.K. Patel, Dr. J.S.K. Patel, sir, and managing trustee. Then now, of course, President Dr. Devanshu Patel and Managing Trustee Dr. Parul Patel, Vice President Dr. Madan Patel, and the then Vice Chancellors Dr. Ketan Kotecha, then Dr. M.N. Patel, now Dr. Amit Galatra. All top management has supported me in every initiative that I have taken, but for their support, it would not have been possible to come all along. Second is the industry, for example. We have been working with Larsen & Toubro in a significant manner. And Larsen & Toubro has a philosophy of supporting education and academia as a giving back to society. And Mr. B.K. Basu, then Vice President, Head of the L&T Power at Baroda, believed in giving back to society, form of giving knowledge to the budding students and faculty members. Our journey has started way back in May 2015 when Royal Academy of Engineering jointly with Federation of Indian Chamber of Commerce and Industry and Government of India organized a workshop at Delhi, and they invited me as well as Mr. Rajan Pandya of L&T Power Training Institute to share our views, the strategic need for collaboration between academia and industry. Luckily, in that program, our session was chaired by then Vice President, Sir William of Royal Academy of Engineering. Then, in the month of September, we received an invitation that they are floating research proposals, whether we are interested to apply for that. When we were present there in the workshop, happened to meet Professor Dr. Ravi Silva, the Professor and Director, Advanced Technology Institute, University of Surrey. A very renowned scientist, himself has more than 100 patents, responsible for millions of dollars funding for the startups by their institution. When we approached him, he agreed to support us as a UK partner. and L&T Power has agreed to be an industry partner. So the kind of support we received from our management, headed by Dr. Devanshu Patel, the president, and Mr. B.K. Basu, L&T Power, and Dr. Ravi Silva, helped us to travel to this extent, whereby we have been able to undertake 4 projects sponsored by Royal Academy of Engineering.
So yeah, based on that, taking a look at your resume, I actually did pinpoint these 4 projects, and basically that's what we're going to be talking about today. So the first project I would like to talk about has to do with the reduction in water consumption when it comes to thermal power plants. So can you basically walk us through the challenges of enhancing heat transfer efficiency and its broader implications on our sustainable future?
Dear Mr. Peter, it is very good actually. See, if you look at the whole world, we have acute shortage of water. Though we have abundant water in the ocean, if you look at the potable water, that is the drinkable water, resources are very scarce. India also has the acute shortage of water, drinking water. Power generation conventionally is done by thermal power, use the coal to generate power in thermal power. India, to the extent of 65% of our power needs are met through thermal power. When we generate thermal power conventionally, we use the steam condensers. The steam condensers consume huge amount of water. When we had an invitation from RAE to apply, we went to L&T and requested them how to begin with. So L&T suggested that in generation of thermal power, we use a lot of water, and there is a way out how to reduce water consumption. The way out is we use air-cooled condensers. But the technology of using air-cooled condensers, not much research work has been done, and we can definitely initiate research work in this area to reduce water consumption using air-cooled condensers in generation of thermal power.
Yeah.
Then, well, in this project, it should be noted that it is a research project. In any research project, it is not by one individual, it is a teamwork.
Yeah.
You need to have teams representing PU, academic faculty members and students, and also you have professionals from L&T and academicians from University of Surrey. At the first instance, I tell about University of Surrey. We had Professor Dr. Ravi Silva, distinguished professor, director, Advanced Technology Institute, University of Surrey, who supported us and guided us through the project. Then we had Mr. Rajan Pandya, supported by 7 professionals like Mr. Somnath Kundu, Mr. Yogendra Mishra, and others. We also had 8 faculty members from Parul Institute of Engineering and Technology who were part of this project. Identifying these faculty members with diversified background and knitting a team is a big, gigantic task. I'm extremely thankful to Dr. Francis Xavier, the then director of research of Parul University, who identified the team members for this project. So we had mechanical engineering team, we had 3 faculty members, Mr. J. Sudhani, Mr. Sanjay Paul, and Mr. Jitendra Chauhan. Then we had a faculty member, structural engineering, Dr. Suhasini Kulkarni. Environmental engineering, we had Ms. Seema Nehlani. And in electrical engineering, we had Ms. Deepa Karabat. So identifying these 8 members in different disciplines, knitting the team and to arrive to go ahead with the project. Now coming back to the exact point which you said about the brother, one of the most important objectives is increasing heat transfer coefficient so that the transfer rate gets increased by studying different fin structures, fin spacing and height, spearheaded by Mr. Sanjay Paul. So see, Mr. Sanjay Paul is the person who headed this particular team. Mr. J. Sudhani worked upon the fan structures, and Mr. Jitendra Chauhan worked on the back pressure. But when coming to the heat coefficient, it is Mr. Sanjay Paul who worked upon that. We compared radial fans, enhanced fins, helical fins in terms of heat transfer and heat flux and pressure drop. And our findings are as follows. Our comparison with the radial fan, it is on comparison with the radial fin. The enhanced fin give 46% increase in heat transfer coefficient. Similarly, the increase in heat transfer coefficient is about 33% and 15% for serrated and helical fins as compared to the radial fin. So heat flux for enhanced fins is 5018.31 Wm square as compared to that of radial fins, which is 2674.918 W per meter square. It is observed that pressure drop in case of enhanced fin is higher by 22%, generated fin as compared to the serrated fin higher by 33% and helical fin higher by 12% as compared to the radial fin. Thus, it can be said that enhanced fin gives substantial increase in heat transfer coefficient with moderate increase in pressure drop. So, heat transfer in aggregate better in case of radial fin. So, we recommended to L&T Power saying that it is better we opt for radial fin, and they took it under consideration of our study and they did study to adopt it in the next tender which they got for auction by a national level company.
So, sir, there's this second project that I'm quite interested in, which was the solar-powered green refrigeration. So, could you kind of like walk us through how that came about and how is it going to contribute to our sustainable future?
This is, Mr. Peter, I am very happy you asked this question. See, if you look at the priorities, we must look at the UN Sustainable Goals. United Nations Sustainable Goals today, there are 17. One of them is environment. Second one is water conservation. The third one is reducing rely upon the fossil fuels. Now, unfortunately, India is still dependent upon thermal power to the tune of 65%. There is no way out to totally eliminate thermal power because you have continuous process plants. Now, continuous process plants, like for example, steel, oil, in these cases, what happens is you need to ensure 24/7 power because continuous process means what? If they stop, then they get spoiled. So you need to ensure 24/7 power supply to these plants. So naturally what happens is you need to have thermal power as a backup. But considering the kind of emissions that come out of the fossil fuels, particularly coal in thermal power, which emit CO2 in a large extent and pollutes the environment and which causes the global warming. So the government led by Honorable Prime Minister Mr. Modi, Narendra Bhai Modi, rightly focused upon promoting solar energy. Now, solar energy merely for lighting, if you look at, does not consume huge amount of power. But what actually consumes huge amount of power is running industries. Second one is refrigeration, or air conditioning. We know pretty well that we use refrigeration and air conditioning in a significant manner, right from February to July, when sun is very kind enough to throw all light on planet Earth, and we get very high level of solar energy generated that point of time. Naturally, we work with L&T, as I said, and overall guidance by Professor Silva. L&T is into thermal power. Now, if you want, you use using the solar energy, how can you do green refrigeration? That is, you need refrigeration because cooling down of the power plant, boilers. So, to maintain the temperature to normal. So, the topic we felt, discussed or finalized in consultation with the L&T Power, and overall guidance from Professor Silva was green refrigeration system using solar energy. That is the idea. To supply energy to 200 TR vapor absorption chiller using solar energy conventionally 15.28 GBP per mj heat energy supplied is required with an area of 1900 to 2000 square meter. There is another important innovation done. We found that ethylene glycol as phase change materials is a potential candidate for a cold thermal storage system to increase the dependence on the solar refrigeration system. There is one more innovation which is extremely worth noting here. This is about experimental investigation and transient simulation of various solar collectors using solar energy for water heating by Professor Murthy. Professor Murthy has undertaken a number of experiments with the help of the students. One of them is nanofluids can enhance thermal efficiency in photovoltaic thermal solar collectors. By experimental investigation, it is found that 15% efficiency of solar panels had increased by using nanofluid in photovoltaic thermometer. There is one more observation and innovative method that our study found out. This particular part of study is heat transfer enhancement in metal foam solar absorber. This was a very interesting innovation, and when we submitted the report to the L&T Power, the L&T Power team studied it in depth and agreed with most of our recommendations.
Sir, presently we are, or rather we've been introduced into a new age in human history, in which we now have smart cities, we have smartwatches, we have smartware, we have everything smart, and all these things are powered by majorly AI. Then you have the whole concept of IoT, and you have blockchain. Now, you're basically moving towards the incorporation of these things into smart cities, and which basically would be a very huge leap when it comes to digital transformation. Now, how do these technologies reshape our urban life? And could you share a successful implementation from your project that has tackled this urban issue head on?
Thank you, Mr. Peter. See, we need to recognize one important aspect, what is happening in the world. Traditionally, we used to say that India lives in villages. That means most of the population lives in villages. If you look at the trend worldwide, by 2035, more than 50% of the population will be residing in cities. And India currently it is about 26%, and we expect that it will go up to 50% by 2035 and 40. So again, it is an initiative taken by the current Prime Minister, Honorable Prime Minister Mr. Narendra Modi, the concept of smart cities. What is the concept of smart cities basically? You try to provide the basic amenities using the modern technology in a simple terms. That means, for example, water supply to the citizens of the town or city, then waste management, properly you undertake the waste management, then you provide energy which is very efficient energy. Also see that your air pollution is properly monitored and properly controlled. Then you don't have transport which causes a lot of air pollution. Try to reduce the air pollution. Similarly, avoid bottlenecks. Sixth important area is you have health. You need to have a unified system of that. So these are the broad areas where they felt that artificial intelligence, Internet of Things, which is called IoT, and digital technologies can play very, very important role. In fact, this idea has come to me. In fact, I should take credit of that because the government of India is rightly focusing on smart cities and made a budget allocation of 5 lakh crores. And in Gujarat, we have 6 smart cities: Ahmedabad, Gandhinagar, Rajkot, Surat, Vadodara, and Dahod. We thought that we must be able to undertake a study which can take us using of AI, IoT, and digital technologies applicable in the 6 areas, starting from water, smart water system, then waste management, then coming to the energy, smart energy management, air pollution, transportation, and healthcare. This was discussed with our industry partners, and one of the conditions of this project, in which the Department of Science and Technology through Department of Electronics and Communication of Government of India is a supporting arm, there should be a startup as a co-partner. So we were able to have Nirveda Technology Solutions LLP, which was founded by eminent personalities from different large companies who started that startup. Then support of NASCOM, COE, Center of Excellence, Gandhinagar. Then we had L&T Sargent Lundi Limited, which is a multinational company, a joint venture between Larsen & Toubro and Sargent Lundi Limited. Then we had the University of Surrey as our guiding force. This project again we have this was led by Dr. Arvind Yadav, who was the professor and vice dean of research of our university. Is a fantastic researcher in the area of communications and smart technologies. This team had again 11 members. Some are from mechanical engineering, some are from electrical engineering, some are from civil. I focus upon three important areas which eventually resulted in innovations. I'm very proud of this project because this was led by Dr. Arvind Yadav in a very exceptional way, and there are tangible results. The tangible results in terms of patents. We have a design patent granted by Government of India, which was developed by Dr. Vishal Sandoval and team. And we also filed design patents in case of electrical engineering and smart water meter led by Dr. Arvind Yadav. And also we have filed for copyrights, which were created by Professor Dheeraj Kumar Singh and Professor Prashant Sahatia. So this project has enabled us to create intellectual property in the name of Parul University. The smart water meter prepared under this objective has demonstrated that the use of sensors, IoT, and digital technology can bring about noteworthy improvements in water management and sustainable smart cities. As I mentioned to you, water is a scarce commodity, and drinking water problem is there across India. Now, how can you be able to monitor the use of water in a meaningful manner? Now, if you install smart water meters which are affordable and you are connecting through IoT to the main system, then you don't have to do manual reading. So you get away with the manual reading. And that water consumption by the household will be known to the household also, as well as to the monitoring agency, so that you can monitor the consumption of water. Since there is a monitoring of water being made by the households, they don't waste water. I think some of the cities already they have taken measures whereby the wastewater recycled will be used for washing of cars, gardening water, for watering gardens, like that. So that you don't use drinking water for those purposes, which can be definitely taken care by the recycled wastewater. So smart water meter developed by our team led by Dr. Arvind Yadav is a very useful solution. And in this connection, we worked jointly with Vadodara Municipal Corporation and Dahod Municipal Corporation, both are smart cities. We acknowledge here the support which we received from VMC as well as Dahod Smart City, in particular by Mr. Manish Bhatt, who is the Director Technology at Vadodara Smart City. This is regarding smart water meter, where we have also used LoRa based water meter system, which is able to increase long distance communication in comparison of Wi-Fi based system, right? The data packet loss can be addressed in future work. Persistent collaboration and assistance between citizens and governing authorities will be driving force for the effective execution and development of smart city. Now, I touch upon another important area where we have made very innovative contributions, that is smart sewage management. As we know pretty well, it is the city of Bombay, Calcutta, Delhi, Ahmedabad, Chennai. In any major city, waste is the biggest problem. It both liquid waste as well as solid waste. Now, how meaningfully you can manage the waste in a smart manner is important question. So our focus is on sewage management system. The optimum operating value is predicted by central composite design for pH, treatment time and airflow rate are 7.5, 149.61 minutes and 35.2 ml per minute respectively. In activated sludge process followed by catalytic treatment of sewage study, application of an activated sludge process followed by a catalytic treatment process for the treatment of sewage wastewater was presented in study. The highest COD reduction, 59.3%, was observed at PS7 utilizing the ASP technique for 300 minutes. We also treated municipal wastewater using microlag and green synthesized nanocatalytic study. Municipal wastewater was initially treated through microlays and maximum COD removal was observed 65% at optimum pH 5. Superstant was further treated with catalyst treatment. The nanostructured zinc oxide catalyst was synthesized by green synthesis method. This study was undertaken by Dr. Vishal Sandavar and Dr. Shiven Saxena, ably supported by Dr. Munati Joshi. That is how in this project we are able to create, they have written a chapter which has been published by Springware publishers also. Another area, important area I would like to focus is transportation system. See, we all know, whenever there is the vehicles are stopped because of the red light. Now vehicles are stopped, they continue to emit emissions. The emissions contain CO2. And today, unfortunately, in India, most of the cities, when you look at the air quality index, AQI, properly, very famously called, the AQI is in a dangerous levels. Unfortunately, the capital city of India, Delhi, suffered a lot every Diwali. During October, November, December, the AQI crosses 700. And even in Gujarat, some of the cities, Ahmedabad, Rajkot, Surat, the AQIs are not very satisfactory. So it is important for us to see how we can improve transport management, how we can see that the vehicles move smoothly and you are able to control and monitor the flow of vehicles in such a way that you can reduce air pollution from the vehicles. So the study basically focused upon developed an adaptive or smart traffic signal system with a simulation and visualization dashboard. We created a dashboard actually and developed a traffic surveillance system to keep track of an in and out of vehicles, if any, entry and exit. And we have proposed system continuous analysis live video feeds to provide comprehensive understanding of traffic pattern and allows for proactive management traffic flow. And proactive signals adjustment can be done by analyzing historical data and incorporating real-time information in the future for the implementation of congestion, so that you avoid congestion in the cities. And this work can be expanded by integrating traffic signal system with Internet of Things devices and data from sensors. And our team headed by Professor Dheeraj Kumar Singh and Professor Prashant Sahatia, they developed the app which has been adopted, which has been seen by VMC, and our team helped them to do better. We have studied both Vadodara traffic system as well as Dahod traffic control system, and we evolved it. And this project also involved number of students in evolving the systems. And another important area I would like to touch upon is air quality management, because it is important, it is imperative to see that corporations and smart cities, it is not merely for sake of smart cities, but you ensure that the quality of life of citizens are better. So one of the things is every human being has the right, Every living thing, in fact, I tell you, not only human beings, animals, birds, they have a right to have a good air to breathe. If you don't breathe good air, you breathe polluted air, naturally your life expectancy will go down. There are a number of studies which have been carried forward which found that if the air is polluted, the lifespan of an individual may go down as much as 5 to 6 years. And these studies are regarding the air pollution in the city of Delhi. It can happen in any other city. So air pollution is important. So how the government, the smart cities can monitor air pollution? They already have sensors set up at different places. Our team led by Professor Seema Nehalani has carried forward the study, and the study validated the data quality of sensors by observing a sufficiently high R2 value, PM10 recorded by Atmos and research grade devices. The extensive use of inexpensive sensors for PM2.5 on PM10 as well as breadth of monitoring system using instruments of reference quality. And the social impact is very significant. Local officials can assess the city's pollution exposure and create a strategic plan for environmentally friendly urban growth and transportation route planning. A network of several environmental sensors can be used to pinpoint urban hotspots for air pollution. For example, any company wants to set up a plant, it needs to get a clearance from Gujarat Pollution Control Board. Now, Gujarat Pollution Control Board must have a clear understanding what is the degree of air pollution in different pockets of the city. You are allowing any company to install a factory, a plant within the perimeter of the city jurisdiction or within near perimeter, maybe 10 kilometers, 20 kilometers. It is necessary for us to assess what is the quality of air and what will be impact delta in terms of the pollutants, whether it is CO2 or nitrogen or sulfur of different pollutants. There are 8 pollutants which are being studied, and we submitted the report to the VMC as well as Dahod Municipal Corporation and Ahmedabad and Gandhinagar smart cities also, because we undertook the study of air quality both at Ahmedabad, Gandhinagar as well as Vadodara and Dahod. The last important point is unified response system improving healthcare services and disaster management. This study was undertaken by Professor Prashant Sahatia and Professor Dheeraj Kumar Singh. This study is extremely important. For example, we are walking, suddenly some vehicle hit us and there is no one nearby. The study innovative device is your mobile, if you shake, very hard shake is given, the signal goes to the nearby hospital. It also goes near to 108. So both 108 and nearby hospital is alarmed. There is some human being with having emergency and they can be ready. So the 108 can spot where this individual is and go on to the individual, pick up the individual and take to the hospital. And this app also provides some vital information to the hospital concerned, saying that this is the emergency, is it a heart problem or any other problem. To that extent, the app provides information to the concerned hospital so that the hospital can make prior arrangements before the patient reaches the hospital in terms of which ward the patient may be sent, whether it is emergency ward or cardiac ward, that they can be decided in advance, because in any accident what happens is your crucial time is 1 to 2 hours. Yeah. The initial 2 hours is a very, very important period. You are able to start treatment of the patient within those crucial 1 or 2 hours, then the patient will survive. Otherwise, they may succumb to the injuries. This is about the app developed by Professor Prashant and Professor Dheeraj, and we also applied for copyright for this app also.
Sir, in relation to the app, how exactly would the app be able to tell what is wrong with the person, or does it just give a general signal that the person is in trouble?
See, app one is accident, it is the general warning only, general emergency is there. But the app also contains other features, health features. So if, for example, I want to get admitted in hospital, I can use the app and I can select the area of emergency. So whether it is, for example, someone is having a cardiac problem, breathing problem, right, like that. So the app gives an options that you select that option, automatically information is flows to the concerned hospital, which problem it is. In case of accident, it is emergency only. But the app contains not only accident but also other options.
All right, sure.
And one more feature that we have done for VMC is VMC was having the need to change their taxation module, because the property tax module, they wanted to bring new features. So our team containing Professor Prashant Sahatia and Professor Denis Kumar Singh helped VMC in revision of this property tax module, and of course the students helped them. This is about the smart cities project concerned, and overall we are very happy say that Vadodara Municipal Corporation acknowledged the kind of support we rendered in this project, and they felt very happy at the end of it.
Well, so you've spoken about smart cities, and we have gotten into an era where the world is kind of like moving more towards decarbonization. India has already started with the policies to kind of like phase out diesel and petrol cars and introducing more of smart cars, so electric vehicles. And you have certain significant contributions in relation to optimizing green hydrogen production. So what are the transformative effects of blending renewable energy with green hydrogen, and how does your work pave the way for a cleaner energy landscape?
Thank you so much, Mr. Peter. See, again, this is a national mission of Government of India. I always believe that the kind of research we pursue at universities and other institutions must align with the national priorities, because national priorities laid down depending upon the needs of the people of India. And Honorable Prime Minister Mr. Narendra Bhai Modi, under his able leadership, found that we need to focus on green hydrogen. Why green hydrogen? Let us first understand that. Because India is highly dependent upon import of crude oil. Because our automobiles, we drive our automobiles using petrol and diesel, and which is drawn from crude oil. And India is highly dependent on import of crude oil. If you look at our imports, almost 80% of imports on account of crude oil. So there are two alternative approaches which are deployed by Government of India to tackle this issue. One is by going for electric vehicles, e-vehicles.
Yes.
The second one is you go for using green hydrogen. Not only by going for electric vehicles and green hydrogen, you are saving foreign currency, but also, most importantly, you are reducing pollution, because these vehicles which use petrol or diesel, they emit emissions contain a lot of CO2, and air pollutants are very significant. So it is a double-edged weapon. One is that you can reduce your forex dependence on import of the crude oil, and second, you can reduce the pollution. And there are twin important objectives. So green hydrogen, it is not new as such in the world, but in India we adopted recently. Our idea is we want to run vehicles with the help of green hydrogen, and the question is how you can generate green hydrogen. Now, one of the important factors is that how we can be able to undertake. Just a minute before I take up that, let me also acknowledge the fact we were able to interact with Linde Engineering India Private Limited. Linde Engineering India Private Limited is the leading player in generation of green hydrogen in India. In fact, its market share is almost about 80% or so. They are the people who are into undertaking projects development for those who intend to manufacture green hydrogen. Then Linde Engineering India Private Limited was kind enough to agree to support us in this research project, which coincides with their business area. Then Professor Dr. Ravi Silva of University of Surrey has agreed. Now we have Professor Satish Krishnamurthy. Satish Krishnamurthy is a great researcher in the area of hydrogen, green hydrogen, and he is our international collaborator. The primary goal of this proposal is to develop an efficient, sustainable, and smart electrolysis system for the synthesis of green hydrogen. See, the focus area is electrolysis system. What is the novelty of our project actually? The uniqueness of our research project is focused on green hydrogen production through smart electrolysis lies in the fusion of advanced technologies such as application of machine learning, inclusion of IoT sensors in reactor, optimal renewable energy utilization, synthesis of novel and economic electrodes, novel electrocatalysts, automation and control systems to the electrolysis process, and its role in accelerating energy transition toward a sustainable future. Moreover, water is the main raw material in the electrolysis process. So what we intend to do is, we don't want to use the pure water for this process. What we want to find out the ways and means through which we can use recycled wastewater, whether it is the water filters, big water filters situated in the hotels, where the water is resultant is left out water. Similarly, the wastewater left by municipalities, we process those wastewater and see whether we can use in this process. And we are using this, what we are trying to do is, we are using the treated wastewater, carbon neutral water, by using rotary membrane bioreactor, and the reactor was developed from the research grant that we received from Royal Academy of Engineering and Technology for our Smart Cities project. This was developed by, as I said, Dr. Vishal Sandavar and Dr. Siven Saxena. Now, what is efficiency? Electrolysis process need to be optimized for efficiency, as electrolysis can be energy intensive. Researchers aim to improve efficiency of the electrolysis process itself and conversion of renewable energy into hydrogen. Green hydrogen production can currently be more expensive than producing hydrogen from fossil fuels. The project likely aims to find ways to reduce production costs through technological advancements and economics of scale. So what we are trying to do is, we are also trying to use material change. So we would like to find out whether aluminum can be used or not. So we have an excellent team on material science led by Dr. Anand Joshi, Dr. Unnati Joshi, and Dr. Mahendra Singh Rathore. The professionals are working on finding out the alternative material, which is the nano material coated. Aluminum is the basic material, because India is very abundant in aluminum, and if we can see whether aluminum can be used in this process, electrolysis process, there is nothing like that. So the team consisting of 3 professionals who are hardcore researchers in the area of nanoscience and nano technologies, they are working on that.
So I understand that you are a busy man, so I would like to conclude this particular segment on this particular note. So thank you for joining us today, and we hope to see you next time.
It is my pleasure, and thank you so much, Mr. Peter.
Thank you, sir. Thank you.